Welcome to part 6 of Competency 6. In this video, we will work with applications of functions. Water was released at a constant rate from a water tank. The measurements are given on the table. Use the table below to answer the following questions. Okay, so we are given time in minutes and height in inches. Okay, one thing I do need to draw attention to is that 90% of the time is our x value here. That didn't work well. So this should be our x, and then height would be our y. Okay, now that we've said that, we need to look at each of our ordered pairs. So 0, 0 would be our first set of ordered pairs. Well, let's go down and look at our graph, our actual number 1. And it says, which graph represents the data in the table above? Well, we need to start at 0, 0. And I can already see that that's going to eliminate this B and D. Now, if we're at 2 minutes, we need 12 inches right here. So I see 2. If I go up 2, but that's over 20, and this says 12. Okay, so let's look at C. Let's go up. I'll have to get this to actually go up. There we go. All right, so we can still see the table. Okay, well, yes, I would say if we estimated, we have, let's see here, 5, 10, 15, 20. So if this is 15, here, let's see here. Get my pen to write again. Okay, so if this is 10 and that's 15, this would definitely be 2 and 12. So yes, C is verified. That's just something you can eyeball, of course. But I know for a fact that the next question involves the table itself. So, right, what we need to do first is, because I know what's coming, and you can look at, let's put it in our calculator and then we'll look at it and answer the question. It's the best way to proceed. Okay. So what do I need you to do? See that table right there? Before we can create the equation or answer further, predictions, figure out predictions. This is what we do. So let's push data, and it's already set up, but it's not set up the way our table is. Okay. So what do? We actually have to use the delete option. Okay, now if you're on other calculators, be careful with that delete. You might need to use clear, but it's safe on the TI-30 family. Okay, so arrow over, delete all that out. Now, what do we want? We are starting at, I'm going to do all the x values first. They need to be in L1. Okay, all right, so all of our x is in L1, and all of our y will be populating L2. Okay, so we have 0, enter, 2, enter, 4, enter, 6, enter, 8, enter, and then 10. Okay, so it went up by 2s. Let's see, actually enter. Okay, now let's pop it over, arrow over to your L2, and it just goes right back up to the top. Now we can look at our L2, which is our y values. So first we have 0, and then we have 12, and then 24, 36. It goes up by 12s each time. And then 48. Finally, we end with 60. Okay. Now you can always arrow up and down and see if it's going to go with what we have in our table. And it does. So we're good to go. Okay. Now I'm going to leave that populating our table, and let's move on to number 2. Okay. Number 2, write an equation h of x that represents the data given in the table. Okay, well, that's why I wanted to go ahead and type it in. So we have our table typed in and we're good to go. But how do we create the equation? Not a problem. Okay, all you need to do, you have everything typed in. If you didn't, stop the video and put it in your calculator. Okay, so we go second mode to back out. Now, I want you to do second data. We used data prior. Okay, now we need to arrow down. See where it says number two var? That's two variable. Okay, all right, meaning that we have x and y. And oh, FYI, h of x actually is our y. Okay, all right, now let's push enter. Well, as I said, our x was in L1 and our y was in L2. So we are good to go. That's set up correctly. So let's enter. Now let's go to calculate. Now, you're going to look at this and go, okay, that doesn't make sense. Now, if you've watched other videos with me, it does. But if you haven't done this before, bear with me. What we need to do is we need to go down all the way down. See how it counts down over here on this side here where you have the numbering, you have 6, 7, 8. Go down, there's 9. And then, of course, you can't, or you're not going to have a 10, but they start with the alphabet A, B, C, D. We want D and E. Okay, what does that give us? Well, A is equal to, here, I'm going to write it here, sidebar, A is equal to M. And B is still a B value of the linear situation. So if we need y equals mx plus b, let's see, our m is equal to a, and a is 6. So we have a is 6, so 6x. Well, that's going to be plus 0. Do we need that plus 0? No. So really, this would be the equation we're looking for. But instead, we have an h of x. So it's just plain old 6x, and that is option A. That's wonderful. Okay, now, what else can we do? All right, using the equation from 2, what would be the height of the water in the tank? What would the height of the water in the tank be after 25 minutes? Okay. Well, that is just 6 times 25. But let's say this was a more complex question. Let's say it went beyond that. Or you had several things they were asking. Okay, so let's do this. Second mode, go to table, clear all that wonderful stuff out, and say 6x, and then just take a look. Okay, let's now see where it says start. Well, they asked me specifically here for 25. Okay, and remember our tank was in minutes, so we're okay. So push 25. Remember, if they had talked about hours, then we would have to convert that, but it was in minutes. That was an important fact. Okay, so, and we do want to go by single integers, whole integers. Okay, all right, so that's good. So just do one, and let's go enter. Okay, for 25 minutes, that is a measure of 150. So there we go. Option B, it has been answered. Okay. So yes, so time was in minutes, height was actually in inches. So that I know that they didn't give that there, but that is 150 inches. Thank goodness they didn't ask us to convert it to feet or anything. But they could have. Okay. That's why you need to go ahead and use your calculator just in case. Now, ooh, we saw more questions. Number 4 is going to keep asking us stuff here. How long will the water run when the height reaches 10 feet? Ooh, okay, that was in inches. Okay, so how many inches is 10 feet? Well, there's 12 inches in 1 foot. So 10 times 12. Well, that is 120 inches. Okay, so we go back here and we arrow down to, oh, there it is, 120 inches, which is 10 feet. So we're looking at C, 20 minutes. Okay, that wasn't too bad. All right, so let's move on to number 5. Number 5, you need to build a fence around a rectangular garden. Which equation can be used to find how much fencing is needed for the garden, for a garden, 60 square yards if one width of the garden is a garden shed and the length is 6 yards greater than the width. Okay. Yeah. All right. So what they've done is they've said, hey, you don't need this part of the garden shed. Okay, now I added in this drawing. I can guarantee you it's in rare occasion do they give you the artwork involved. So this will have to be sketched by you on your test. Okay. So we just have width. Let's call it W. And why am I calling you W? W for width. And suspiciously, all we have are a bunch of W's here in our ABCD options. Okay. But now the length is equal to 3 yards greater than the width. So that'll be 3 plus W or W. Either way, it's W plus 3. The length is 3 more. Okay, 3 more yards. It's a little bit longer. All right. So, what do we need to do? Well, we can call length W. Okay, we're going to call that W. Okay. So, the area is 60 square yards. So, the area is 60, and we know area equals width times the length, right? Okay, and we also know that the perimeter for our purposes is W plus 2 lengths, 2L. However, we know a kind of a value of W, or we know we know length in terms of W, L in terms of W. Okay, so that 60 equals the width times, well, what is our length actually? This is my length right here. So we need to do a little bit of substituting. The name of the game, obviously, from looking at the ABCD options, is to get everything in terms of W. Okay? Now I see this. I see W squared plus 3W. However, that isn't going to satisfy me, okay, because of this. I also see that the perimeter equals W plus 2 lengths, or 2 times L. Well, what is L? W plus 3. Okay. All right. Well, let's take a look at that. What are we really looking at? Well, if we look at both of these, well, we need to not look at perimeter because I think that will come in later because the question says, all right, which equation can be used to find how much fencing is needed for the garden. So we're not looking at the actual perimeter or going down to what is W, what is L. Really, what we're doing at this point is looking at. So I'm going to get rid of this. We don't need perimeter, although it'll be important later. You've seen it. You may want to have to come. In fact, I think we may have to come back to it. Okay. What we need to do is solve this situation here. Okay. So really, what am I saying? I want to use this and I want to use my 60. Okay. Let's put it together. I see W squared plus 3W. Does it look familiar yet? And then equals 60. But to create a proper equation, I need to subtract both sides by 60. W squared plus 3W minus 60 equals 0. Now that eliminates D and B, and also A is eliminated because of this plus. If you don't follow through on your algebra correctly, those positive negatives will get you. So C is verified. Now that we've done that, we have an equation that'll help us out. However, now it's actually asking us for that perimeter I had earlier. Remember what I had? Let's read the question, see what it says. Using the equation number 5, that's above us, find how much fencing is needed for the garden. For a garden, 60 square yards if one of the sides is a shed and the length. So they're kind of repeating, and now they want the actual perimeter that we needed. Well, we needed one width, right? And then let's see, they're just asking how much fencing is needed. So that's just the perimeter or the three sides of the perimeter. So I'm going to say W and then W plus 3. The glitch is uh-oh, no. I wrote that wrong. Sorry. I looked over. Wrong equation. Wrong equation. That is W plus 2 times W plus 3. Okay, now let me continue. Once I made a very big mistake, I could have led you down the garden path, which is terrible. Okay, so that's our perimeter. Okay, so we need to find what W is. How do we do that? We go back up here, we take this equation that we created, put it in our calculator, and find where, here's the big thing. You need to find where it equals 0, okay? All right, and that can be tricky. All right, so go back to our table, clear this out, and remember, naturally, we don't have a W to put in the calculator. So W will equal our X, okay? So each of those should be X. So X squared plus 3X minus 60. Let's enter. I'm going to start at 0, okay, because I'm really not sure where I'm going to end up. So let's enter, and enter. Well, we definitely know that over here on our right-hand side, we're not interested in the negative values, okay? And it's quadratic, so we could have positive negatives. Oh, looks like, see how we went from negative 6 to 10? Looks like we're somewhere in between 6 and 7 or W value. So the width, and we need the width right now. Okay, so let's push clear. Go down here to our steps of 1, and I'm suspicious. So I'm going to put 0.01 and push enter. A lot of times that works. And enter. Okay, all right. Yeah, and it kind of bounces you up a bit. So, I mean, see how we're going down? Remember, we were going down from -6 to -10. Wow. Okay, maybe we need to go to down further. Okay, let's see here. Let's start at remember we were in that zone from 6 to 7. So how about 6.5? Let's start there because it really bounces up really far. Oh, okay. This looks a little more promising. Okay. I kind of went halfway in between, but looks like that took us a little bit too far. Remember, over here on the right hand side, we're looking for 0. Now, you could just manually calculate this by using your quadratic formula. No, but I'd rather show you the calculator. You could use the quadratic and then verify it on your calculator, and I think we've just verified it. Okay, see where we have 6.39, and then look, we have negative above it, and then it bounces up to 0.16. This value here of 0.0021 is very close to the 0, which means that we have a rounding situation. So I would go with the 6.39. It's probably closest, okay? But I would say it's good enough for our purposes. So let's say W equals 6.39, and we will put that in to our calculator with this being substituted. So second mode, okay, now 6.39, and then say plus 2 in parentheses, 6.39 plus that 3, close the parentheses, double check our entries and enter. Ah, yeah, we've got a very solid answer, which is B. There we go. So our calculator really did help us. Now, if you have time, you feel like you have time on your test, go ahead and verify using that quadratic formula. The quadratic formula is not a big deal, but this way I'm showing you how to get a good estimate with the calculator. And if it you have time, you can pop back, do it by hand, and then double check with your calculator. And I've done both. It will verify. It's a good answer. All right. So let's go on to number 7. Number 7. Determine how long it would take an investment of $4,867 to become $8,000 if it is invested at a rate of 5% that is compounded quarterly. Okay, in order to get the formula for this, it is provided for you on the formula sheet that will be embedded in the computer while you take the test. It is in the program or on the test, however you want to see that. So you will get this. This is what you need. A equals P. And then in parentheses, 1 plus whatever your percentage rate is over the number of compounding times during the period, and then times the n times t. N is for number of times compounded, t is for time. In our question, they're asking you to find t. So t is what we're looking for. Now let's designate the other items. A is the $8,000. P is the 4,867. Obviously, your R or your rate is 5%, and N is 4 because that's what quarterly means. Okay. Now, we're going to do this by hand. Then we're going to show a method to do it very quickly in the calculator where you can quickly get super close. And that's what you're going to need to do. Please note that your answers are in years. T is assumed to be in years for this equation, for this formula that's been given to you. Okay, so let's do that. I have 8,000 equals 4,867. Oh, my handwriting is interesting. Let's Okay, 6, 7. Then we have 1 plus. Set up my fraction, 5% over the 4, and then that's exponent of 4 times whatever t is, okay? Now, how do we tackle this? The first thing you need to do is you need to get t as much, clean it up, clean things up to get t on its own. Well, we divide both sides by 4, 8, 6, 7. By 4 sides by 4, 8, 6, 7. Now what happens? Everything in front of the parentheses equals 1, so it goes away. Now that we've gotten rid of that, we need to apply the natural logarithm or a logarithm. I prefer the natural log. Apply it to both sides. So this is what you will get. You will get ln of 8,000 over 4,867, and that is going to be equal to. Now, I'm going to apply the natural logarithm. When I do that, this exponent of 4t comes down. Now, a lot of people bring it to the front. You do not have to bring it to the front. You can put it on the back, which is a little more convenient and cleaner to see for this problem. So, ln of parentheses 1 plus 5% over the 4, and then that is going to be times 4t. Okay? Now remember, and I'm going to make it a little clearer, that the 4 is multiplied to the t. And at this juncture, let me do there we go. At this juncture, I need to mention again or remind you that it's t. How long does it take, which is our t? We need it alone. Well, if you look at how I've set it up, everything in front of the t, we can take all of that and multiply both sides by it. So I have ln of 1 plus 5% over the 4 times 4. Okay, now over here on the other side, I have ln of 1 plus 5% over 4 times 4. See, notice that times 4, you can put that in the front of the back because it's multiplying. That's why I was saying it really doesn't matter. Okay? Now, what is really going on here? Well, everything in front of the t is going to be that understood 1 we were looking for. So it all equals 1. So now we know now that's my right hand side. On the left hand side, that's actually what we want to put in the calculator. Okay, so I know that t, or my time in years is going to be some estimate. Okay, and you may say, notice like some of my videos, I write everything out and put it all in the calculator at the end. That is to prevent rounding errors. You could end up with rounding error here. I see some numbers here that could easily be an error. So that's not my habit. And also that kind of lets you keep up with what I'm doing. So I have ln fraction, doing the numerator first, of course, 8,000. Then that is over the 4,867. Arrow over, close parentheses. That's one of my habits. Now, my denominator is ln again, and then I have 1 plus, set up another fraction, and that's 5. Now, I am going to call that 5 a percent. I am not going to change it to a decimal. Well, how do you do that? Second, and you see that parentheses there, the open parentheses. My percent is above it, okay? Now I arrow down, and that is n is equal to 4. Then I arrow over, close my parentheses. Now I can just type in 4 here. You don't have to say times 4 because the calculator understands the order of operations. Okay, now drum roll, push enter. What do I get? A little teeny tiny bit more than 10 years. Okay, so roughly 10 years. Okay, all right. Now, if I put in 10 exactly, it's going to get a little bit less than $8,000. That's what I'm saying is if I wanted to check this by putting 10 years in way back at the beginning and recalculate, I wouldn't quite get 8,000. But let me show you what I mean. That took me a while to calculate that. You don't have to do this on your test, okay? This is what I need you to do. Remember everything that I put in. Let's clear all that out. Push table. This is what I have put in. Remember where I started, okay? Notice that, here, yeah, I've already changed colors. Okay, notice this, okay? I started with 8,000 equals 4867 parentheses 1 plus 5% over 4 for t. Now, in the calculator, t will need to equal x, okay? So what am I doing? I am doing this. I am putting everything on the right hand side into the calculator, and then I'm going to see when y, here, let me change colors, when y is going to be 8,000. Okay, basically. How do you do that? Well, this is how you do it. Enter it in using the table like I've done in other videos. Type it exactly how you've written it out. Exactly what the formula would look like. Okay? Now push enter. Now I am going to, yeah, I have it. It's starting my table starting at 0 and my steps are 1, but I'm actually using ask x to get what I need. So go over. All right. And we're checking that 10 years is what we're doing. Watch this. I've already done it. Look at A. A is 8 years. Well, I'll redo it for you so you see exactly what to do. Remember, we only have 3 lines here. Okay. First, if I say 8 years, that's A. If 8 years is X or my time, that's not enough. That's not close enough to 8,000. Now let's type in 9. A little bit closer. Now let's type in 10. Ooh, that is very close. So it's approximately 10 years, but not perfectly. It's very shy. We got a 50-cent discrepancy. Okay. Now I'm going to go back up and type over the 8 and show you what 11 would be. 11 is way too much. If we wait 11 years, we're going to get over $400 more. So we don't have to wait the 11 years. Obviously, 10 years is close enough. All right, now let's look at number 8. All right, okay. Use a scenario to answer the following questions as indicated. Okay. The cost of mailing the cost to mail a letter in the US starts at 73 cents for a standard sized rectangular envelope weighing up to 1 ounce. Okay. Each additional ounce will cost 28 cents up to 1 pound, which is 16 ounces. For a letter weighing over a pound, there is a flat rate of 9.35. Okay, so this is a piecewise function situation, okay? Meaning we have 3 pieces, okay? You have the first range. that'd be 73 cents. That goes from 0 to 1 ounce. Okay, let's look at our options. A, okay, 0 to 1 ounce. Okay, now it says up to 1 ounce. Now notice it doesn't say including the ounce, but we do. Let me tell you why we do. Because the wording here says each additional ounce costs 28 cents. So that implies that we do include that. It's not just up to, it's including. So we do need right here, see this? X is less than or equal to 1. And notice how they have it. Okay. They went ahead and gave it to you because it is valid. Okay. Now, each of those seem to be correct. So that's good. That's the first part. That's the first part of the piecewise. So let's go to part 3 of the piecewise issue. Each additional ounce will cost 28 cents up to 1 pound or 16 ounces. Now, let's think this out. The letter, if we go, you have to think of, okay, if I'm under an ounce or under, it costs this. But what if I'm over? Well, it's the 76 plus, okay? Plus what? Well, for the ounces that are over 6, it'd be, okay, 1 ounce, it'd be 2 ounces, 3 ounces. So you have to subtract that ounce when you multiply it times the 28, okay? 1 ounce is 73. That's like a B value. You have to think of 73 cents as your B value. And then it's 2 ounces, 3 ounces, 4 ounces, up to 16. So now, thinking about that, look at A. I don't like this because they have the B value is being 28 and multiplying. See how your X, that's X minus 1? Well, that's 2, 3, that's all the other ounces times 73. That's backwards. So no, I don't like that. We are getting rid of A. That's just not going to work. Now, B, option B, I like their beginning value. They have a B value, but then they have 28 here and nothing happening. And this is correct. I like this. But 20, we can't just take, we had a range. It's 28 cents for all the additional ounces, 2 or 3 or 4. Well, it doesn't multiply times anything. That's not what the wording says. It just is, it doesn't say, oh, 73 cents and then just add 28 cents until it gets over. It doesn't say until it gets to 16 ounces. That's not what the wording says. So I'm not going to buy that. Doesn't make sense to me. Let's look at C. I like the way it starts for the first one. Check on that. And then it starts with the right B value. Okay. You're past an ounce, so it's 73 cents. Now we're going to add on 28 cents for all the other ounces over 1 ounce. I like that. I like the way this looks. And it's including the 16. I like that. So I'm going to check mark on that one. Let's go to D. Well, it kind of looks like D also satisfies it. But D is lacking one major thing. It does not talk about the flat rate past 16. Okay? The flat rate, it doesn't include it. And that's where it breaks down for me on D. So we have to go with C and mark out D. Okay? All right. So that all being said, the way this question, it says use a scenario to answer the following questions as indicated, meaning that we need to go to number 9 and we will be asked to follow through. So you might want to snip this take a little screenshot or go back a little and take a screenshot where it was clean and come back to number 9. All right, let's move on. Number 9. Which of the following represents a graph of the scenario above? Okay, if you remember I said take a picture of that, the piecewise situation. From 0 to 1 ounce, and including 1 ounce, we should have 73 cents. So let's go all the way up so we can see everything. Okay, so let's look at A. Well, I see 1 and 73. Well, that makes sense. Let's look at B. Again, at 1 ounce, we have 73 cents. They've given us the coordinates so we can, judge it correctly. But now let's look here. At C, it's 1 that's the 28 cents. And that was, actually, that was an invalid option. Okay, so C won't work. Okay, so now let's keep looking. Let's go back to A and B. Now remember, we went from 1 ounce, greater than 1 ounce, and above that, up to 16 ounces. It had to include the 16 ounces. And remember what it was. So let's go to our calculator and type that in. Okay, what do we have here? I already have it typed in. We had the first ounce plus 28 cents. The first ounce was 73 cents, then plus the 28 cents, but it would be times all the values minus 1, minus the first section, minus the 1. Okay, so that being said, let's see what those values really are. So let's push enter. And let's start at 16. Okay. And let's go up by values of 1, see what happens. And keep it on auto because we want a list. Okay. Oh, $4.93. But we cannot look at 17 and 18. Okay. They're not going to be in our piecewise. But all these others are. And then look what happens when we go to 1. See where it's still at 73 cents? Well, that's because that's how we wrote our equation. So that looks very nice, which would be, I'm saying that, meaning B. Okay. Because, and the reason I like it is because we needed to include the 16 ounces because that's the way it was worded and shown in our options. Okay. So I'm going to say that B is what we want. And then 16 here is good. Now look at what it says above that on B. It says, well, it's 16 ounces. Don't include the 16 ounces, but everything here that goes out will be $9.35. And just a flat rate. I like it. But look at what happened on A. Ooh, they just kind of miscalculated and put it in there at the six. I don't, honestly, I don't know where they got $6.35. I mean, let me see here if we even have that. Maybe I think what happened is if you calculated incorrectly, that would be what you got. See, that doesn't make sense. I'm not sure how that popped in there. Okay, but obviously A is incorrect and B is what we want. Okay, all right, let's go to number 10. Number 10, what is the cost of mailing a letter that weighs 12 ounces? Okay, we're still using our scenario. Ah, but we should still have that in our calculator. So go back to the table and see how that is all in there. Remember, what we have in our calculator is from 1 to 16 ounces. Well, 12 is definitely within that interval. So let's go and check what 12 ounces would be. So enter and type in 12. Okay, that for the starting, we want to start there because that's what we're looking at. Okay, enter. Oh, $3.81, option B. Nice. Okay. Now let's look at 11. For a letter that costs $2.13, what is the possible weight? What is its possible weight? Well, just arrow up and go back and let's see how close we can get. Ooh, we actually don't get close. We get right on the value. And it's actually 6 ounces, option C. Okay, that's really convenient. Our calculator actually helps us quite a bit. Nice. Okay. All right, let's go to number 12 here. Let's see what it says. A middle school sold 525 tickets to a winter carnival. Okay. If the adult tickets sold for $7 and the student tickets sold for $5.50 with total ticket sales of $3,150, how many adults and students attended the winter carnival? Okay. All right. Even though I had a term get hard, I'm having a hard time talking, getting it out of my mouth. Let's figure this out, okay? This is what we have. Okay, I am going to say that, let's say adults are X. Let's see, how did I say? Yeah, adults are X and students are Y. Yeah, let's go with that because let's see. All right. So we know that this is the total of tickets sold. Well, tickets represent people walking in the door. Okay. So let's say that we have, I don't know how many adults, plus I don't know how many students equals 525 tickets. Well, that would be the people. Okay. That's who walked in and paid. Now, how much did each of those categories pay, and we have a total for that. Okay, so the cost of X adults is $7 times the adults plus $5.50 for each child, which add those two together, we have 3,150. Okay. Whenever you have those situations, here's how you know that you have this system. Do you have two totals? Yes, I do. I have one for tickets and one for money. Well, then you need to back it up, kind of read between the lines, and think about what do you really have. And this is a very common scenario, very common word problem, and it can be asked in many different ways. Let's say it's trees and bushes. You sold 150 of trees and bushes. Well, that gives you your first sentence, your first scenario, your first part of your system. And then it said, oh, well, trees cost this much, bushes cost this much, and now here's your total of sales. Well, it's the exact same thing. It is what it is. Okay, so what do we do? Well, we need to solve this system, but we're mostly going to use a calculator. I'll be honest with you. So what do we do? This is what we do. Let me change colors here. Let's look at this guy first. And let's say y equals 525 minus x. And that will be what we use. This is the expression that we will use to put into our y. Now, we can actually put that in the calculator. And if you watch the other videos with me and you know what I did, this is what we need to do. 7x plus 5.5 in parentheses, 525 minus the x. Now, subtract the 3,150 from both sides. Minus 3,150. 0.50, and that means we'd have 0 on the other side. Now, this is what we put in the calculator, and we're looking for a 0 on the right-hand side. So let's do all that. Okay, second mode to pop out, clear the whole thing, and I see 7x plus 5.5 in parentheses 525 minus the x, close the parentheses, subtract 3150. Yes. Okay, now this should get us what we need. Okay, let's push enter. Geez, I'm looking at my A, B, C, D options because I'm looking, it says, where do you want to start? I don't want to start at 0. I'll be going up and down and arrowing all day long. Forget that. I'm going to start at 155. Okay? 155. A whole lot less arrowing. I'm just saying. Let's see if we get lucky. So we don't have to do too much of that business. Okay? All right, or we could do the ask. Ooh, no. Let's go back up. Okay, go to auto. It's there. Now let's go to ask. Let's not even do that. And enter and enter. So this is old stuff from a prior question. Delete those. Go down, delete. Now go back up. All right. Let's try 155. 155. Okay. Oops, that's not 0. Remember, we're looking for the 0 right now. We are not looking for the no. Let's see. No, the X is the adults, right? Ooh, we're looking for the 0 to see what the X is. Okay, so let me erase this. X equals adults. So we have to keep our brains straight. So we're looking at these. So probably best to put in 175, the smallest one. 175. Ooh, that's 0. Ah, that's pretty nice. Okay, so I'm looking that A would work, but let's try the others. Oh, we have 350. Right, 350. I know I'm kind of bouncing around, but you can see where I'm at. No, that doesn't work. Ooh, I don't like that. 740. Right. Nope. Nope. I don't like that either. Now let's go 370. 370. Mm-mm. No. Looks like 175 is the only one that works. But we still have to follow through. How do we follow through? We take our 175, okay, and we put that in for this X, okay? So we go second mode and just back out. And this is where we need to say 525 minus 175. Cross your finger, we should get 350. Push enter, and we do. Verified, it is option B. Okay. All right, that's great because it's the last question in this video. And I hope I was helpful. And thank you for watching to the end of the video. And again, you subscribers, you are phenomenal. Thank you very much. Greatly appreciated. And if you liked us and shared us with other people, that is amazing. Thank you again. Guys, happy testing. I wish you the best.